A Rolex can take around a year to move from raw metal to finished watch. Some parts inside are smaller than a grain of rice. Yet the final watch must handle water, shock, wrist movement, and years of daily wear. To see how that happens, the process starts with the metal. The first stage is material preparation. Rolex uses stainless steel, gold, platinum, ceramic, sapphire crystal, synthetic ruby, and many special alloys. For many steel watches, the case and bracelet begin as Oystersteel, a corrosion-resistant steel from the 904L family. It is difficult to machine because it is tough, but that toughness helps the finished watch resist sweat, salt water, scratches, and daily use. Raw bars and blocks are inspected before cutting begins. For gold models, the process begins in Rolex's own foundry. Pure gold is mixed with other metals to make 18-karat yellow gold, white gold, or ever rose gold. Since pure gold is soft, the alloy uses 75% gold and 25% other metals to improve strength and color. The mixture is melted in furnaces at temperatures above 1,000 degrees Celsius. Once liquid, the gold is poured into molds, cooled, and formed into bars. These bars are rolled and pressed until they reach the right thickness for cases, bezels, bracelet links, and small parts. The watch case is one of the first major components to take shape. Steel or gold blanks are loaded into computer-controlled milling machines. Cutting tools spin thousands of times per minute and carve the rough case shape. The machines hollow out the center, drill openings for the crown, cut threads for the case back, and shape the lugs where the bracelet will attach. Coolant flows across the part to reduce heat, because too much heat can distort the metal and change the measurements. After each cutting stage, measuring systems check the case. Optical scanners gauge and coordinate measuring machines confirm the dimensions. The space for the movement must be exact. The case back threads must close securely. The crown hole must line up with the winding stem. Even a tiny error can affect water resistance or movement position. Parts outside tolerance are rejected early. The bracelet is made in a separate flow. A Rolex bracelet is built from individual links, screws, pins, clasp blades, and locking parts. Metal bars are cut into small pieces, then milled into link shapes. Machines drill precise holes so links can be joined later. At this point, the links look rough. They have tool marks, sharp edges, and unfinished surfaces. They are sent through grinding, brushing, and polishing to create the final feel. Brushing is done with controlled abrasive belts or wheels that create fine straight lines in the metal. Polishing uses rotating wheels and polishing paste to create a mirror surface. Workers guide each part carefully because too much pressure can soften the edges and ruin the shape. Too little pressure leaves marks behind. The goal is clean shine, sharp edges, and smooth contact against the skin. While the case and bracelet are being shaped, the movement parts are being produced. The movement is the engine of the watch. It includes the main plate, bridges, gears, mainspring, barrel, rotor, escapement, balance wheel, screws, jewels, and calendar parts when the model has a date. Many flat parts are cut by precision machines, gear teeth are shaped with special cutters, tiny screws are formed and finished. Synthetic ruby jewels are used as bearing points because they reduce friction where metal pivots turn. The parts are extremely small, so cleaning is critical. Before assembly, movement components are washed in special cleaning machines. Ultrasonic cleaning uses high-frequency vibration to remove oil, dust, and metal particles. Assembly begins with the main plate. Jewels are pressed into the plate and bridges. Then the gear train is installed. Each wheel must sit between jewels with almost no friction. The watchmaker checks that the wheels spin freely. If one pivot is bent, the entire train can lose power. The barrel is assembled with the mainspring inside. This coiled spring stores energy when the watch is wound. In automatic models, wrist movement turns the rotor, and the rotor winds the spring. Lubrication is one of the most careful steps. Special oils are placed on selected contact points in tiny amounts. Too much oil can spread and collect dirt. Too little oil creates wear. Some drops are so small they're barely visible without magnification. The aim is to reduce friction while keeping the movement clean for long-term use. Next comes the escapement and balance system. The escapement releases energy from the gear train in controlled pulses. The balance wheel swings back and forth, while the hairspring controls that motion. Many Rolex movements beat 28,800 times per hour, or 8 times per second. That rhythm is what divides time into steady parts. When the balance is fitted, the movement begins ticking for the first time. The movement is then adjusted and tested in several positions. A watch is not always flat on a table. It may sit crown up, crown down, dial up, or move constantly on the wrist. Testing machines measure how much time the movement gains or loses in each position. Watchmakers make small adjustments until the rate stays within strict limits. Rolex movements are also tested for chronometer performance before the finished watch receives final internal checks. The dial is made in another department. A dial begins as a thin metal disc. It is cut, stamped, and finished. Some dials are coated with lacquer. Some receive a sunray finish, made by fine brushing from the center outward. Printing is done with pad printing machines. A soft silicone pad picks up ink from an engraved plate and transfers it to the dial. This creates sharp text, minute markers, and logos. Hour markers are produced separately. They're polished, placed, and often filled with luminous material. The luminous compound must be smooth and even, so the watch glows clearly in the dark. Inspectors check the dial under magnification. A dust speck, crooked marker, uneven print, or small scratch can lead to rejection. The hands are also made from thin metal. They're stamped or cut, shaped, polished, and filled with luminous material when needed. The holes in the hands must fit tightly onto the movement pinions. If a hand is loose, it can slip. If it's too tight, it can damage the pinion. During assembly, the dial is attached to the movement, and the hands are pressed into place with hand-setting tools. The hands must sit parallel to each other. They cannot touch the dial, crystal, or one another. The watchmaker turns them through a full cycle to make sure nothing catches. The case is now prepared for the movement. Gaskets are installed around the crystal, crown, and case back. These seals block water and dust. The sapphire crystal is fitted into the case. Sapphire is very hard and resists scratches, but it must be installed cleanly and evenly. The crown tube is fitted, and the crown is checked for smooth winding and secure sealing. The movement, now carrying the dial in hands, is placed into the case. The winding stem must pass through the case tube and connect properly to the movement. This stem lets the wearer wind the watch, set the time, and adjust the date on date models. Once aligned, the movement is secured. The case back is screwed down with controlled torque, tight enough to seal, but not so tight that parts are damaged. Water resistance testing comes next. The watch may first be tested with air pressure. The machine checks whether the case changes shape under pressure, which can reveal a leak. Then water pressure testing confirms that the seals work. A dive watch is tested to much higher pressure than a dress watch. If water enters the case, it can damage the movement, stain the dial, and break down lubricants. This is why sealing is tested so strictly. After sealing, timing is checked again. A movement can behave differently once it is inside the case, so the finished watch is measured in different positions. Machines also test the automatic winding system by moving the watch in patterns that copy wrist motion. The power reserve is checked by fully winding the movement and measuring how long it runs. Many modern Rolex movements can run for about 2 to 3 days on a full wind, depending on the movement. The bracelet is then assembled and attached. Links are joined with screws or pins. The clasp is fitted and tested. It must open smoothly but lock securely. On sports models, extension systems are checked so the bracelet can adjust over clothing or during wear. Workers test link movement, clasp snap, screw tightness, and bracelet alignment against the case. Now the watch enters final inspection. Under bright light and magnification, inspectors examine the case, bezel, crystal, dial, hands, bracelet, crown, and clasp. They check for scratches, dust, uneven brushing, poor polishing, loose parts, and alignment problems. Date models are tested to make sure the date changes correctly. The crown is wound and pulled through its positions. The hands are moved again. The clasp is opened and closed. Once approved, the surface is cleaned one final time. Protective films are placed on polished surfaces. The model and serial information are recorded. The watch is matched with its card, booklet, tags, and presentation box. Packaging protects the watch during transport and keeps the finished surface safe from scratches. A Rolex is made through thousands of small checks, not one single dramatic step. Every cut, seal, screw, gear, oil point, and test removes a possible failure. By the end, the watch is no longer just metal, glass, jewels, and springs. It is a small mechanical machine built to keep running, second after second, on a moving wrist.